Okay. I guess okay. I don't have any questions written down, but I guess like, would what if any would you say is like maybe like a narrative or like an overarching like theme that like unites like I don't know the kind of problems you're interested in or the kind of methods you're interested in solving those problems in like your current work or whatever.
Um, yeah, so
Or do you find that there's like a common theme that ties those things?
um, at this point, I don't know if there's a particularly common theme. I think, we're getting to explore a lot of different interests. But at least, throughout my PhD and postdoc, I'd say, a lot of the problems that were interested me were ones that had, very interesting mathematics that then, showed up in real world problems. So I've done, relatively little in it, but I think, single particle cryo-electron microscopy is sort of, one of the coolest problems out there just because of the underlying math problem so interesting, and that drove a lot of my research early on, I guess, things like that.
Okay. I guess what is like what or like I don't know if I'm allowed to ask like what are like the kind of current projects that you're working on that I guess you're like most excited about, or like the current directions that you're most excited about.
Yeah. So we're working on quite a few things in my lab, ranging from radar tracking to event cameras, imaging through scattering. I think the couple of thrusts that I'm super excited about are imaging through scattering media, and sort of by extension imaging through turbulence and imaging through aberrations. And then partially in service to that goal, sensor fusion. I think that's a problem that we're only recently having sort of the computational budget and like the tools and techniques to solve that well. So I'd say those are sort of the two main themes in my lab, and then there's a couple dozen different projects touching on those to some extent.
I'm also curious. I don't know if this is going to be like a well-formed question, but like I guess you mentioned like cryo-EM and you mentioned like scattering media. Um, I wonder like does this like kind of like require like very strong physics background? Like your like what is your like own like understanding of these problems? Like do you have like a very strong understanding of physics, or do you like kind of just approach these as like purely just like mathematical models that you just like take it just like these mathematical models that like create some sort of image, or is that like or is there like inherently some sort of like deeper like interest in like the physics of it or something like that, if that kind of makes sense.
Yeah, so I guess I probably know less of the physics than I should. I'd say I know enough of the physics to understand the problems and scope them out. Um, I think everything we do is abstracted. We once we frame it as a inverse problem. I think that's where my group and sort of I have some strengths. So I'd say that's our general approach to problems. Is sort of what's the simplest model for the physics that's accurate, and then run with that. I think something we're moving more and more towards is actually doing actual physical experiments, and that requires a lot more physics knowledge, and sort of it's something we're figuring out as we go.
Sorry, kind of in like the same vein, like I'm curious like how in that case do you kind of like get started on those problems in the first place? Like how do like I guess like cryo-EM is like something like is like a pretty interesting problem, like kind of well established, but like who was the first computational like imaging scientist who like did cryo-EM, and how did that collaboration like come out? Like how do these like new problems that arise in physics, like how are you made aware of them, I guess, and then and like does that require like a lot of like collaboration with like the actual like biologists or physicists that like from where like those problems actually originate? If that kind of makes sense.
Yeah, that's a good question. I don't have a great answer for. I'd say attending a lot of conferences and sort of having a sort of diverse range of invited speakers is sort of a good way to learn about problems you would otherwise know about. And yeah.
Okay, cool. I guess sorry for like another related question in that vein. But like it's also, kind of also related to the first question I asked you. But like, how have you, I guess, how have you seen like your interest like evolve over time, and like what has driven that? Do you think, like your research interests? I guess.
Yeah, so I think my career, sort of research career, I really haven't known exactly what I want to do. So when I first started out, I chose, the signal processing group because signal processing hits everything. So it meant, you essentially didn't have to choose. You learn how to use algorithms, and now you can apply them to XYZ problems. And at first, I knew the algorithm. After that, I knew the algorithms and not the problems. And then during the latter half of my PhD and postdoc, sort of picked up the optics to actually, you know, apply some of these algorithms to real systems. And that's sort of been the loose trajectory of my research, I'd say. And we're trying to, now build up more and more of those actual hands-on optics expertise in my own lab.
Oh, okay.